water, it would be impossible to get it out of the truck, down the chute, into the pump, place it, move it around, consolidate, and finish that concrete mixture. So to improve that workability, additional water is added, and as much as 60%. I think the limits on ACI is 0.7 for water to cement is maximum, and that's going to be on the flowable side. So that additional water is referred to as the water of convenience. And then let's not forget, on some projects, things do happen. Trucks get stuck in traffic. They get held up in line at the project. So oftentimes, while the mix design may be scheduled for a 0.5 or a 0.45, additional water out of necessary means is added. So what does that mean for us on the floor finish side? Well, that means that, first of all, we have to be thinking about how long it's going to take to cure. General rule of thumb is for every 1 inch, it requires 1 month of drying time before the moisture levels can reach that to where we can consider covering it with floor coverings. So we all know that every concrete floor will require some amount of surface preparation. But why so many issues with flatness? Is it poor workmanship on the concrete trade's part? It's really not in most cases. Sometimes, obviously, but generally, it's the concrete itself. Now we've gone through the water part, and it's not uncommon to find a project that's been mapped out, pinned to require up to 2 inches or more of leveler. I like to show this particular map job because here you can see we've got 0 measurements, and then we've got 2-inch measurements no more than 15 or 20 feet away. So as you look through this, you can clearly see the waviness index is moderate to extreme on this project, and this is quite average. So let's step over and go through what our flatness requirements are for our various floor coverings within our industries. So for ceramic tile and stone, dimensional stone, we know that TT Mac calls out for a FF of 50, which we'll talk about in a moment, or 3 millimeters in 3,000 millimeters, or the equivalent to 1/8 of an inch and 10 feet under a straight edge method. That is the same tolerance that the American National Standards Institute calls out for tile and stone as well. They also go on to state that, there should be no more than a 1/16 of an inch variance in 2 feet. So no sharp changes. The Tile Council of North America, same language as well. So what about wood flooring? Well, the National Wood Flooring Association calls out for 1/8 of an inch up to 3/16 of an inch in a 10-foot radius using a straight edge method also. They defer to the manufacturer of the wood planks in way of what the actual tolerance should be. As wood planks have gotten wider and longer, they're typically in that 1/8 inch range. So now we can see some consolidation between tile, stone, and wood. Well, what about resilient floor covering? Well, the ASTM, or American Standards for Testing Materials, calls out for 3/16 of an inch in 10 feet for resilient floor covering. So that's your LFT, your sheet goods, and your LFP. The National Floor Covering Association also calls out that same exact language, 3/16 maximum over a 10-foot span. Now remember, the manufacturer of the vinyl or the resilient floor covering, their requirements will trump any requirement. So if they're more stringent, meaning if they're at 1/8 of an inch based on the size and dimension of the floor covering, then that would apply to the project. So where does flat begin on a project? Well, flat is going to begin on the architectural side using concrete design methods. Here you can see you've got the Cement Association of Canada and the American Concrete Institute's instructional guides for design of concrete floor slabs. And we're also going to touch into the tolerance compatibility under ACI 117. So let's start with 302 and 117. 117 mimics the language from ASTM E1155, which quantifies FF and FL numbers. This is floor flatness and floor levelness numbers. It's a quantitative way to determine how flat a concrete floor is, and it's also a quantitative way to specify or design what the floor flatness or floor levelness should be on a project. Now we can see here that tolerances are developed by specific means or executed on the project. So strike off in formwork and whatnot can set the way for levelness, and then flatness is determined typically in the finishing process of the concrete placement phase. Looking at ASTM E1155, you can see that there are some specific requirements in evaluating a concrete slab that has been placed. So when testing that floor, first of all, the process for the concrete evaluation for FF requires that you cannot cross any construction joint in your mapping or quantification of what was actually executed for floor flatness. Also, you can see that no measurement should be taken within 2 feet of a slab boundary. So at the edges, you work your way 2 feet in, then you can begin your measurements. Also, no construction joint, isolation, blockout, or similar discontinuity. And that's all related to anticipated shrinkage. The anticipated shrinkage goes back to that additional water of convenience that was added that's necessary to place the concrete. So now we can begin to see how the concrete industry develops their design, quantifies their flatness, and understands the anticipated shrinkage of the concrete. Let's talk about how FF numbers are taken from 1155. Here you can see one of the first tools or methods. One of the first products was from the face company called the dipstick, but basically it's taking measurements in a grid every 12 inches. Now, to improve production, rolling profilers were developed to do the same thing. So it can be done much, much faster. Newer technologies allow for laser scanning. You can see here a 3D imaging map with thermal indicators on variations in the flatness. And to take it even one step further, we now have drones being used as well to do the same thing with the laser mapping or LiDAR scanning. What's coming? Something interesting. Hyundai's trying to develop a finishing machine that can take the software program and use LiDAR or laser scanning and finish the concrete to the designed or specified FF numbers. So let's take a step closer into the design guide from ACI. This is out of 302. So the concrete industry outlines these flatness options to the designer or the specifier or engineer on the project. So conventional, moderately flat, flat, very flat, super flat. Obviously, there's an associated cost from going from a conventional flat finish through to a super flat. So why would I pick one over the other? Well, the design guide helps you categorize your floor finish within the facility to associate it with a moderate or an FF number related to that floor covering that's going to be specified. So here we can see carpeted spaces would be in that conventional, or moderate rather, and the thin set tile would be an increased FF, and then all the way down to your FF50, which would be set for specialty applications or usage. So let's relate it to moderately flat. For carpet, tile is your flat or FF of 35, And you can see here in 302 that we've got some association between a FF number and a 10-foot straight edge. But what we can also see as we look at this, that the tolerances that are used in this design guide are far from where we are today in way of minimum flatness tolerances or allowable flatness tolerances. Where we need to be is in what they call the super flat range for our tiles because of their large format. So as we step back over into ACI 117, we can see a comparison chart in way of finishes for the ACI. These are their tolerances on the right, and you can see that they're saying, hey, we're going to give you 1/4 of an inch and 10 feet for your ceramic tile floors, regardless of what the finish requirements may be from the ceramic tile industry. So now we can begin to see that disconnect between what we require for floor coverings and what the concrete industry can deliver. And that brings us to that gap or that division between 3 and Division 9, which I wanted to put this up because this is an important document. It's been around for a number of years, but slowly over the course of time, other industry organizations have begin to endorse this document. It's a great document, and you can find it from the ASCC. This is position statement number 6. And what it says, in a nutshell, basically what we already know, is that the measurements from FF do not correlate to straight edge measurements, and that by the time floor finish comes onto your average project 4 to 18 months later, the concrete has changed in flatness from what it was delivered after concrete placement. So the tolerances are obviously not compatible. This is a fantastic document. I urge you to download this for your company and your usage. So the biggest, best part of the takeaway here is there is a statement in there that says a bid allowance should be allotted for any necessary floor preparation in relationship to the floor coverings selected. So now we've set the foundation for no matter what floor covering you're going to specify. They may vary from a carpet to a large format porcelain tile, but there is going to be some required floor preparation necessary, and there should be a budget allotment for that. So that sets us back into ACI 302 under the committee report that clearly also acknowledges the gap between Division 3 and Division 9. So now we have the American Concrete Institute, we have the ASCC, or the Concrete Contractors Organization, and all the floor covering organizations stating and agreeing to the same current condition. And that's that gap between concrete being placed correctly and floor finishes needing additional surface prep to meet flatness requirements. And that all ties us back to the nature of concrete, really. I mean, it's still the best building material, but it's impossible for concrete to be placed and then go through its curing process as it loses that additional moisture or water of convenience that is not necessary for hydration. As that evaporates, the concrete volume is going to change, and there the surface flatness is going to change with it. So that's what, drives the need for self-leveling products. I mean, as wood planks get larger, as porcelain tiles get larger, the surfaces need to be flatter. And not just for floors. That includes walls or any areas that they're going to be installed over. So, I want to have a quick conversation about what's called slab relaxation or reverse curling. So, lastly, just to touch on organizational acknowledgement, even the Ready Mix Association acknowledges curling and water loss and dimensional change. There is a ACI 302 committee report on this reverse curling. I would suggest that you get it. And here it goes through step by step in the process. So the concrete contractor places and cures the slab. There's no curl. We're talking about within the first 48 to 72 hours. After that, that slab is going to begin to curl as it loses moisture. And then the floor covering contractor arrives at a much later date in most cases and begins the preparation process, grinding high points at cracks or joints or just where it's curling at edges or isolation joints. And then applies surface preparation materials. Maybe it's patching, maybe it's leveling, maybe it's a combination of the two. And then installs a floor covering in depiction number 4. Floor covering contractor leaves, everything's fine. But what happens after step 4 is that moisture that it's at the bottom portion of that concrete slab, because the surface part of that slab has lost its moisture through evaporation. That moisture begins to redistribute now because it can't continue to evaporate at its own rate. So as that moisture redistributes, it's similar to a sponge that's being re-wetted. After it's curled, it will begin to lay back down. So now we've got that slab relaxation or reverse curling after the floor covering has been installed. So that means once that slab lays back down, if you've got a rigid flooring like tile or even wood, it's going to go into compression. And once that floor covering goes into compression, there is only one place left for it to go, and that's going to be up. So not all of these failures that are happening out there can be attributed to a lack of movement joints being installed in the assembly. It could be that slab relaxation or reverse curling. Now, early stage leveling or early full floods can actually help reduce and prevent that reverse curl because if you cover the floor at an early stage, you sidestep or prevent that segregation and that moisture loss at the surface, and the redistribution of moisture happens early on and remains that way before floor covering is installed. So something to consider on your projects is doing an early stage leveling, full flood, and the ESL can also have moisture mitigation involved. So if you have resilient floor covering going over that surface, especially in healthcare, that can be a huge advantage for permanent protection. And you can see volumetric changes are reduced dramatically with early stage leveling because it keeps that moisture in that slab, which is great for strength gain long term. So let's step into where we are currently for self-leveling underlayment in way of installation or industry standards. Currently, we have ASTM 2873, but I want you to note the title of it because this is for the installation or preparation prior to the installation of resilient floor covering, not for wood or for tile or other surfaces. But it is a great document. And quite honestly, it's applicable across the board in way of floor coverings because it just talks about, contaminant shouldn't be there. It also mentions other floor coverings that may not specifically be intended for it, but could be utilized. And that comes out of ASTM F710. Also, there's a comparison chart between FF number tolerances as well. So there's a nice correlation. No TT Max standards. Currently, it is mentioned a few times, and I'll tell you where. The note to specifier. Tile contractors, and this is a note that is basically a statement from the CFCA talking about the gap between FF and it's impossible to deliver a super flat in a standard sense. So I like the statement here. The contractors who wish to obtain surface tolerances in excess of FF 25 and 35 will need to include allowances to level the floor with a mortar bed or self-leveling screed to suit their needs. That's a difficult task for a contractor in most cases because That's an extra work order conversation, and on larger projects, that could be a big dollar amount. Also in TT Mac, where self-leveling is currently mentioned, you'll find it in detail 314, which is basically for your electric heating cables encapsulated by cementitious self-leveling underlayment. It's also mentioned in the spec note on spot bonding. So basically what it's saying here is spot bonding is not a proper installation method. It creates a lot of failures. And to avoid that, self-leveling underlayment should be specified and used. But it also talks about the financial dilemma, almost forces some contractors to go into a spot bonding method. So really, it's elaborating on, hey, we've got a gap. It's turning out poor quality work, and we need, as an industry and whole, we need to really work on closing this gap and talk more about self-leveling standards and dollars in the budget.
Yeah, I think we've lost Will. I'll give him a phone call. Yeah,
So while we're waiting for Will to unconnect, did we have any questions so far?
Will's trying to connect in just now, Lisa.
Maybe just one point I could bring up since we got a little bit of time. And I don't know whether Will's going to talk about it, but if you look at our 09300 master specification that Keith Robinson put together, he's very cognitive of these issues, and he's put in there that there should be allowances for self-leveling and to be able to meet the requirements of the tile industry versus what the concrete industry's flatness and level requirements are. So if you do look in the manual, there's quite a bit of information. Keith was very cognitive of that, and I think we're covering ourselves pretty good there because it's in both the general and in product section talking about the need for self-leveling.
Where's that, Dale?
The back of the 093,000 manual. It's our master spec.
So that's a good point, Dale. That really covers the architects, and in getting the proper substrate for these installations is having that allowance in there.
Right. Yeah. It's an often, it becomes a big arguing point because it means basically almost renegotiating the contract, as Will was mentioning. So by having it in the actual spec, it should make it so it's not an argument point. It's clear and defined.
We hope so, but sometimes with the GCs, it's always a fight.
Oh yeah, I know.
Yeah, that's going to come up into my segment where I talk about the discussions that we have and who is in charge of the quality control.
Yeah.
Kemster, I hate to say it, but you're kind of stealing my thunder a little bit on mine as well, because that is something that we'll touch on both from the architectural side of things as well, and how the industry as a whole moving forwards is trying to mitigate that.
Sorry.
That's all good.
All right, I think I'm back.
There we go.
We're glad to have you back.
I do apologize.
Had to feed the hamsters.
Yeah. Okay, everybody see my screen? We're good? All right.
Yeah.
Screen here. Okay, so TCNA guidelines, you can see them on the screen. Cementitious self-leveling underlayment is mentioned in 9 details. The National Floor Covering Association talks about hydraulic cement underlayment, HCU, self-leveling, if you will. So that's our current mentionings of our self-leveling standards. That's where we are today. And I'd like to turn it over to Mr. John Alley to begin his conversation. John, floor is yours.
Thank you, sir. All right, so we'll start off with the first slide, if you will. There we go. So I want to put a caveat in from the simple fact that, you know, there are good specs that exist out in the industry. The vast majority of the specs out in the industry are good, but what we see as well from an understanding and a realization in the industry is there are certain areas that maybe don't have as much emphasis put on them as from the tiling industry or from the finished trades industry that we would like to see. We see specs that exist out there where there are little to no mention of specific standards. Many of the ones that Will brought up, whether it's CSA or ASTM or whatnot, or as a whole, there's specific sections within Division 3 that are missing. So it runs into the issue that how do we solve that? And when self-levelers are mentioned in some cases, they're incredibly vague into what's going to be done or what the performance requirements of it may be. So it leaves it up to interpretation in a lot of cases. And as Will mentioned as well, both in the bidding stage from the GCs and the bidding stage from the trades itself, it's how much money are we going to bid on this? And how are funds going to be allocated? And as well, when it is contractors bidding on this, it's are the contractors or the trades bidding apples to apples? Or is one trade going in at a, for sake of argument, low $20 a bag product, and another trade is going in at a higher 20 or lower $30 a bag product because they understand the complexity of the installation? And generally speaking, this doesn't really become present or raise its ugly head until during construction, when, as Will pointed out, it's okay, we've now got an issue on the concrete. We're trying to install tile, carpet, flooring of any kind. How are we going to mediate that concrete? And in a lot of cases, it puts the trades in a really tough spot. Will, if I can get you to go to the next slide. So, you know, as we can see, there's your trade. They're stuck in the middle. So how are we going to fix that? Next slide, Will. You know, in a lot of cases, unfortunately, what happens is from the photo in the bottom there, you get a lot of finger pointing. And from the trade standpoint, you get a lot of, well, just figure it out, make it work. And if the trades are asking for documentation or reporting into what the conditions of the floor is, there's little to no documentation that's been there, which in turn creates confusion within the installation itself, because it's now, well, whose responsibility is this? Are we going to look at it as the GC responsible to mitigate or remediate the concrete? Are the forming contractors going to come back and fix that? Or is it going to be dumped on, what we tend to see a lot of cases, is it going to get dumped onto the trades themselves to have to fix that? As well, from the understanding that we see unreal expectations that after that FF testing is done, 3 days after the slab is poured, there's this unreal expectation that the concrete is going to maintain that FF rating moving forwards. even though from the simple aspect, and I think the general understanding from the industry, is that concrete's going to move. We all know it's going to move. In most cases, we can anticipate it will move, curl, cup, whatever you want, up to 20%. So how are we going to fix that? And as we tend to see a lot, especially with larger commercial towers, residential mixed use, whatever it may be, ownership groups have already allocated X amount of dollars to complete a project. And by the time it comes up where there's a general understanding that the concrete's going to have to be remediated, the ownership group may have an unwillingness to pay out more money to fix this. So then we get into, personally, my favorite term in the industry, which is value engineering. What are we now going to start to remove or change to be able to mitigate the additional costs that we start to see with self-leveling? And in a lot of cases, and especially with installations today, we see a lot of these 5 foot by 10 foot panels or 24 by 48 tiles being used that do cost a premium. Okay, well now let's reselect. Let's maybe look at something a little bit different. Next slide, please, Will. So, and Will mentioned this as well, but in a lot of cases, what we see in Division 9 from different associations and different manufacturers across the industry is very vague requirements that exist. In some cases, and I was flipping through some technical data sheets from some vinyl manufacturers earlier this week, they had a line written into their technical data sheet that said the substrate must be plus or minus a 1/4 inch. Well, if you're going to straight edge test that, you have a 1/4 inch low on one side, a 1/4 inch high on another. Realistically, your slab's out 1/2 inch, but that falls within what that manufacturer's recommendations may be. Also industry as a whole, we're moving away from the standard 12 by 12 tile where your floor tolerances may be been able to be a little bit looser. Generally the industry standard outside of the tiling section, but more so into concrete, industry standard for a slab on grade is going to be an FF35, 1/4 inch over 10 feet. And for a suspended slab, we're looking realistically an FF25 or 3/8 of an inch over 10 feet. And the reason behind that with suspended slabs, and suspended slabs are a whole different animal altogether, but you're going to have far more movement into a suspended slab, especially if contractors are trying to speed up installation or speed up construction as a whole, and they're removing that shoring or that supports before the concrete's had the opportunity to fully cure out, or at least cure out to a point where you're going to have less movement than before. As Will mentioned, and as I've said as well, we are starting to see larger and larger tiles. 5 foot by 10 foot panels are not uncommon. And what's mentioned within the TT Mac and what has become kind of an industry standard now is we're looking for FF requirements of a minimum 1/8 of an inch over 10 feet. So who's now going to pay to ensure that that substrate meets the tolerances that are there? Or better yet, where is that mentioned within that Division 3 or Division 9? I've got a little excerpt from a spec here that's at least 10 years old, but surface tolerance of 1/800. What does that mean? How does that get interpreted by the trades themselves? And as Will mentioned, in a lot of cases, because there isn't the necessary budget to remediate or repair that concrete, we run into the issue of installers having to cut corners because they don't want to have to take the onus on themselves financially because they're not going to get that money back of having to repair that concrete. And we start to see poor installations or improper installations being done to mitigate that. Yes, we have large and heavy tile mortars that exist in the industry. Yes, they can be troweled up to 3/4 of an inch thick, but the analogy of, I'll just put more mud on the floor and hope for the best isn't going to solve the problem in cases like this. Next slide, Will. So that's how the industry, in some cases, and as I said, the industry is not all bad. There are a lot of good spec writers. There's a lot of good architects that exist in the industry. There's a lot of good specs, but the vast majority is there's a lacking in some way, shape, or form. But I'll pass it off to Craig, who, as mentioned before, is a director of the TTMAC, as well as one of the head project managers at Creo Stone here in Vancouver. Craig?
Hey, thanks, guys. Yeah, there's probably many contractors and folks here that probably have better qualifications to jump onto this, but I have plenty of experience with poor floors, and as Mike pointed out, nobody wants to stand behind the next step of who is correcting the floor. As you can see, I have very few pictures in my phone, but I dug out a couple. This is just one, weeks ago. We get into a situation so that, that's a 10-foot straight edge. Right away, you see the problem, and everybody sees these. The question that I have is who is actually the one to inspect the floors ahead of time that was supposed to meet a certain standard, and I don't think there is anybody that is other than our own contractors in most situations. And even then, sometimes when there is a engineering firm or somebody in-house of the GC, they just do a quick scan and they're not using the straight edge, right? Next slide, please. Yeah, and here's another one where there is corrections that have been made. Somebody comes in, they put down a self-leveling, and it could be flat. Most of the time it's not, but we often get delamination situations where I had a project years ago where the very, very top floor, the premier tenant, they had the floors all dead flat, but they needed to add another thickness to it. So they put another self-leveling on top, which then delaminated the entire floor underneath. The two systems bonded together, but not to the main substructure. Next slide. Next slide. Next slide. And again, you can see this floor has been corrected, but nobody checked it. I mean, that's a ½ inch gap underneath there. They just came in, spend the time, but nobody's spending the money because nobody wants to pay to have the remedial work done. Next slide. Yeah, this is from a picture from a friend of mine at Align Flooring. They have, you can see a rained out slab that, that's turned over to them, that they're supposed to jump on this and put down, whatever flooring that they were going to be putting down. Obviously you can't. So they have, your shot blast prep, you're doing whatever. But then other flooring toppings that we get, they're full of gypsum or fly ash. A whole other world of problems that come in with these type of surfaces. Next slide. Yeah, and then moisture, yeah, can be obviously a huge problem, but there's mitigation solutions that I think everybody can reach out to some of their partners and get a hold of. Next slide. Yeah, this is just a typical thing that happens. No matter what happens to the main slab, the floor is could be dead flat. But then you've got all these other conditions that happen. You get cleanouts, you get electrical conduit, you get all kinds of things, and there's we need to have a better coordination of these so that they can have a variable, so that when you're coming in and the floor is only going to be 11 millimeters thick and they've got it up at 15, we need to have some of those coordination solutions taking place. Next slide. Yeah, just go back to the last slide. One of the things that I see a need for is a link between the GC, the architect, so that the owner is in the know that there is going to be additional costs if the first standard isn't met, and the first standard can't be met because, like Will's stating, with all the curls that are happening as the concrete is curing, it's just inevitable that there's going to be but there's a big missing link as to who is in charge of that communication, and where it boils down to, and some of the contractors that are on here and everybody else, they realize that it's not a discussion. A lot of times it is an argument. It is frustration on the subtrade, because they just want it to go away. Everybody wants the problem to go away, and they want us to take care of it, and nobody wants to come out with any extra costs. So we end up doing it for as low as possible, which means that we have lost opportunity cost. Like, we don't want to be correcting floors. We want to be installing the floors or walls, depending on whatever's out of plane. Yeah, back to the next slide. This was actually just a very unique situation. We had a bridge. So the bridge has a curvature to it. I think it was probably maybe like a 4 or 5 inches overall, and the concrete pour was so poor that we wanted to come up with a solution. The preference on a bridge, because of the deflection, is unbonded. So instead of doing fill, we actually went through, marked it up, and they had to lower the floor. You can see on the right hand side, the 1/2 inch. Many locations we lowered the floor in order to have an unbonded system that went right through. And I think that's it, isn't it? Well,
That is.
yeah. All right.
All right, great. Thank you, Craig. So what we'd like to cover now is what's coming. What work has been done? Where's the resolution? So, as mentioned in TTMAC, the 2021 spec guide, you are going to be seeing a new ANSI standard for self-leveling underlayment. However, we've added a different title, which includes flowable hydraulic cement underlayment. And we'll explain that in a moment. So, we have a new material standard coming. It's currently in ballot. So we hope to have that passed soon and published sometime mid this year or later this year. And then we also have an installation standard, A108.21. So let's dig in a little deeper. We wanted to make sure that there isn't a misunderstanding from the terminology of self-leveling underlayment, which kind of grew from a marketing perspective. Believe it or not, we've had many people expect the material to actually self-level. That's not what it does. It seeks its own level. For those that have used it, it's pretty obvious. It's like water. You can put it in a glass, and if you move the glass, it's going to seek its own level, just like water would. But it does not self-level itself. So in the material standard, we wanted to make sure it's intended to be used in flattening the underlying substrates from the work performed by others prior to the installation of natural stone and tile. Now, it can actually level floors. It can be achieved, but it's going to require more material, absolutely, to level a surface. It's also going to require an extensive amount of surveying, and the engineering needs to work with it, because transitions, terminations, casings, window mullions, etc., all play a role when you're going to lift that surface up much more than 1/4 or 1/2 of an inch. So leveling can be done with these products, but it's a separate scope. So right away in the material standard, we wanted to, set the foundation and make it clear that the majority of use is for flattening, but they can also create a level space when needed. Same language was put into the installation standard. So we also wanted to make sure that flowable hydraulic cement was included, because this ties us with Division 3's understanding of this type of material. So now we can more closely connect Division 9 and Division 3 in way of repair materials. so that, if Division 3 decides to provide the corrections before Craig and his company go in to install floor surfaces, now they have a material standard and they have an installation standard with language from their side of the industry, and it's actually a technically correct terminology. So this is all tied together in the coming material and installation standards. John, back over to you.
Thank you, Will. So I know we've got a couple of minutes left here, so I'll quickly fly through some of the last slides, and to some degree, this process does exist already in the market, but what we're seeing is a higher emphasis and a bit larger emphasis, both from a commercial and a residential standpoint, on the construction organizational process and how we move forwards with that. So what we start seeing a lot more now is the collaboration of specification writers, the architects, the designers, the engineers coming together and selecting the floor based off the need of that space itself. Next slide, please, Will. Thank you. From there, what we're doing is we're now going back to that concrete. We're taking in standards from the American Standard Institute or ASTM to ensure that that concrete or that substrate is going to be able to meet the tolerances set out by the flooring itself that's going to be put into that space. Next slide, Will. From there, once again, we're cross-compatible, kind of cross-analyzing that with other ASTM or ANSI standards to, once again, ensure that what's written into the specification when it comes to that bid phase, everyone's playing apples to apples. Everyone understands the performance requirements of that concrete itself or that substrate itself, and the expectations of what's going to be required from the GC, from the concrete forming trades, as well as from the flooring trades themselves. Next slide, Will. And then lastly, but not least, once again, bringing in other organizations like the TTMAC, the guidelines and the requirements based off for what's put in there, or the NFCA or any of the other organizations that exist in the industry to ensure that best practice is used moving forwards. Next slide, Will. So, and Dale brought this up in our little bit of a interlude when we were waiting for Will to come back, but we're starting to see improvements brought in even the beginning of Division 1. There are several groups out there, several organizations out there that are trying to write new sections to solve the problems that exist. One in particular, and I can see there's a couple people on the call that sit on this committee with me, but we've brought together a group of individuals that consist of architects, specification writers, material manufacturers, both from the concrete side and the self-leveling side and the flooring side, as well as structural engineers and different trade organizations to come together to create a new specification that will have a uniform layout of what's the acceptable tolerances of that concrete or that substrate. What are the mixing and placing requirements that are going to be needed to ensure that less cost is going to be put onto the self-leveling? Bid requirements, how much money is going to be put aside, how that's going to be allocated moving forwards, and the eventuality that, yes, there is going to be some sort of self-leveling or patch, but how are we going to pay for that? And lastly, creating a uniform language that goes throughout the spec regardless of what section or division it's in. And yes, that does exist within the spec itself, but one of the big shockers that came out of me from sitting on this committee is what some trades on the concrete placement side would use and what we use in Division 9, same word, same term, but mean completely different things. And it's creating that uniform language so everyone understands that, okay, when we're talking about flat, this is what flat means. And as well, in the last point with what we're seeing a little bit more out of this new section in the specification is there's a lot more emphasis on pre-construction meetings and scheduled meetings throughout the entire construction phase, so there isn't any more surprises. So everyone can come together, both from the design component and the architectural and engineering component, all the way down to the setting, the trades themselves that are going to be putting this material down on the floor. So there's an understanding of what's going to happen. Next slide, please, Will. And then improvements within Division 3. We're starting to see larger, more in-depth versions of 0335 or 0354 that are including a lot of the standards that Will and Craig and I have discussed throughout this presentation. We're starting to see different standards being used across the board. A perfect example, and one that Will used earlier, was ASTM F710. That's starting to be used not just to define what the resilient flooring is going to be, but the requirements that may be used as well for the tiling section or other sections as well. And unfortunately, some of the photos aren't showing up on the slide, but what we're also seeing as well is better definitions of what that area and what that space is going to be used for. You know, we're not seeing the just generic open place the floor has to meet FF35 or FF40, whatever it may be. But we're seeing a better definition of certain areas are going to have carpet, certain areas are going to have large format tile. An area over there, that's all parking garage or hospitals. We're all going to require different FF ratings as well as different concrete surface profile ratings for those areas based off the needs. Lastly, once again, what Will brought up, you know, we're starting to see newer technologies also being written into the spec to obtain those FF and FL ratings. We're starting to see a lot more point cloud surveying being done rather than just the standard dipstick test, which is done 72 hours after the slab is poured. You know, the great thing about a lot of the point cloud surveying is it can be done on a continuous basis so we can understand, okay, yes, the concrete meets FF35 for sake of argument after 72 hours, but let's see how it's going to move and expand or shrink and curl through that curing process. So 8, 9, 12 months later, whatever it may be, when the trades come on to set tile or set flooring, we're already going to know what the concern or how much money or how much time is going to have to be allocated into surface preparation. Next slide, please, Will. So lastly, when we move into Division 9, one of the things that we're starting to see as well is new sections of specs like 090561, common work results for floor preparation. This removes the self-leveling aspect of the concrete patching aspect out of Division 3 and into Division 9 and makes a single section that combines all the requirements for all the flooring trades that are going in. So regardless of whether it's carpet or if it's hardwood or tile or whatever, there's one single place for that to go into. You know, and as we all know, tiles are getting larger and larger. I mentioned that in some of the slides before, and those tolerances are getting tighter and tighter, so we can have more uniform tolerances across the board. There's far less work stoppages or far less concerned about how much money is going to have to be allocated to something because it's already been mitigated. As Will brought up earlier, you know, whether we're going to do an early set pour, whether we're going to do full flood pouring, or if we're going to do spot leveling to try and mitigate those issues. But also what comes out of this is there's a better understanding from the ownership group, from the design consultants, from the contractors and the trades, what's all involved. There's no shock and awe of, oh man, the concrete's really out, so we need to repair it, because it's better written into the specifications as they exist right now. You know, Will mentioned it as well, but we're starting to see a lot of ASTM standards or other standards that maybe are geared more towards the resilient flooring section starting to be implemented with the tile section as well, because in some cases those tolerances do vary from material to material, and it's already a preset standard that everyone already understands, as well as the newer standards that are coming up, like what Will mentioned earlier with ANSI A118.16, you know, our new upcoming standard for cementitious self-leveling underlayments. And the emphasis more on construction meetings and ongoing meetings to ensure that, you know, it is going to work, as I said, with the point cloud survey. Also, and this one kind of comes back to the new spec in Division 1 as well, but we're starting to see the emphasis more on full mock-ups being done, not just to ensure that the tile is going to be able to be bonded to that substrate, or there's enough shear bond strength depending on what it may be, but ensuring that the concrete and the toppings that are going to be put on it can meet the tolerances that exist there, and as well as all the components can work in a system altogether that's going to uniformly work without any surprises. And we do see it where maybe there's an inferior topping that's put onto that concrete that may require additional sealers or preps or maintenance or grinding to ensure that we're going to be able to bond a waterproofing membrane or an anti-fracture membrane on top of that and be able to bond that tile or glue or adhesive to that to ensure that the entire system's going to work. Next slide, Will. And I'll pass it back off to you.
Well, this is, I thought this photo was kind of suitable in way of timing and where we are. You know, a lot of efforts behind the scenes. John mentioned it, the standards. More work to be done, though, right? We can see that we're beginning to complete kind of a backbone or a foundation of closing that gap, but we still have more work to do. And how long it's going to take for these new standards to get in and filter through the project, you know, that still remains unanswered. But generally, I know we have some architects on the line and consultants. I'd say typically you're looking at 2 to 4 years probably. But the good thing is the awareness level is there, and hopefully we can get to a point where there's no more battles over the cost of surface prep to do it correctly, and there's no more cuts or pushes on production schedule. And I like the better communication and more pre-con meetings. So what I'd like to do now, or what we would like to do, I should say, is we'd like to open it up for any questions that any of you may have that are online. Violetta, I think we turn this over to you, but before we do, here's all of our contact info. If you have any questions for any of us later, we're going to make sure and provide that as a resource as well.
Okay, so there were no questions submitting during the presentation, but let's see if anybody has any questions now.
I have one. I heard a lot of good things regarding the changes and updates to standards, putting some division portions of division 3 into 9. Craig mentioned a self-leveler, going over another self-leveler. Specific to what was, if you could clarify if it was said, the actual profile of some of these sub-leveling methods, in that I come from a history maybe more on the terrazzo side, but certainly has involved tile. But for example, these are all good technologies, nothing new about, for example, getting the hardness levels up there to the 3,000 to 5,000 PSI. But for example, a concrete surface profile specific, are those things being included in some of these new specification guidelines? For example, a concrete profile of 5.
It's a great question, Brad. Yeah, that conversation is in some of the language. However, with newer technology,
Oh, it looks like we're possibly losing
the rheology. Am I here?
Sorry
Can
about
you
that,
hear
Will.
me?
Yep, we can hear you.
That's okay. Newer technologies and primers and cement rheologies, we don't require the higher profiles that we used to offset anticipated shrinkage and the cycling of the self-leveling underlayments. But it's still going to be somewhat use related. So heavy industrial use, yes, you should have a higher profile. Common office use, no, you don't need a 3 to a 5. A 2 works fine. That's an ongoing conversation right now, but certainly the conversation about burnishing a slab, excessive power troweling, and curing compounds is still another challenge that we're working on, without a doubt. I mean, potassium silicates are all a challenge. Carbonation is a benefit on one hand, and it's counterproductive on the other. So, one thing at a time, I want to say, but the coordination between 9 and the concrete industry has gotten much, much better. So we hope to be able to solve some of those other challenges, that you don't have to be concerned about a curing compound on a project that's incompatible with your floor covering adhesive, be it a thin set, a primer, or an adhesive, or a wood glue. So great question, Brad.
Brad, just to add to that from what Will was saying, we are starting to see it implemented more into both Division 3 and Division 9, where those specific requirements are being written into the spec. So in the case of argument with self-leveling underlayments, generally the industry is looking for a CSP3, and we're starting to see that being written into the specification to ensure that there's not that oops factor, I guess, that comes into play after the concrete's been poured and cured out and prepped. But it's, oh, we can't work with a CSP1, or as Will said, we can't work with a burnish slab. We need to come in and now shot blast